In this video, we are going to cover HISAC Ultima modules and connections to be made to perform the test. Scope T&M is a pioneer in circuit breaker testing. We have now launched HISAC Ultima with DCRM Plus, which operates with both sides grounded. For more details, keep watching this video. In this video, we are going to show how the connections are to be made to do the testing efficiently with both sides grounded. Both sides grounded provides additional safety to the operator as well as to the person making the connection at the circuit breaker end. Before going ahead and learning how to make connections, we will first look at what our HISAC Ultima consists of. HISAC Ultima is a modular design. The kit has 8 modules in a standard HISAC Ultima configuration. Let's learn more about each module. We will name the extreme left module as Module 1 and the extreme right as Module 8. Module 1. Mains inlet socket with a slow blow fuse. Power on-off switch with lamp. Ethernet port to connect the instrument with Windows-based software installed in the PC or laptop. Master earthing ensures instrument and operator safety against high induction in the switchyard. Module 2. DCRM Plus Power Supply Module. Each DCRM Plus unit is equivalent to 2 DCRM channels. Thus, unlike its predecessor DCRM, which requires 6 channels DCRM for conducting tests. For simultaneous measurement of 3 poles with double break, you would require 3 DCRM Plus units. This module has 3 connectors and switches to power up 3 DCRM Plus units respectively. Module 3 Breaker Control Module. For testing of circuit breakers, we need to operate the breaker through the instrument. For this, we have to extend the DC positive to the close and trip coil of the circuit breaker, and this is controlled by this module. This DC positive voltage is routed through the fuse to protect the short circuit or damage of coils. To test breaker operation through the kit is of utmost importance. To achieve the same, we use breaker control module. We can see that module is divided into 2 halves. Upper half consists of 3 slow blow fuses to protect coils. Lower half consists of breaker control of close, trip 1, trip 2. In software, you would get a command error in case your wiring is incorrect or there exists a problem with the fuse. Module 4. Travel and Coil Current Module. To check the healthiness of the mechanism, a travel channel is used. For this, transducer is connected to the mechanism of the circuit breaker. The travel measurement of the circuit breaker contact is very essential as it helps you to understand various parameters like speed, contact gap, contact wipe, over travel, rebounds, etc. You can measure the travel of all 3 poles simultaneously. Scope offers a rotary or linear transducer as per the circuit breaker mechanism. Optional transducers are available for any range of circuit breakers for AIS and GIS. Coil current measurement is also an important parameter. It helps you to understand the healthiness of the coil. If you look closely, you can understand this module is also divided into 2 halves. The upper half for travel measurement through 3 connectors T1, T2 and T3. Whereas the lower half consists of the coil currents channel 1, channel 2 and channel 3. Module 5 Timing Module. It has to be used only when the timing of the circuit breaker is to be measured and no other tests are to be conducted, which is a rare phenomena. When you would do the connection with DCRM Plus, the use of this module is not required. Timings would be measured through DCRM Plus module itself. The connector details of this module are as shown here. Red, CB end 1. Green, common. Blue, CB end 2. The above set forms 2 contacts, thus we can see there are 6 sets of combinations, thus the instrument can measure up to 12 main contacts timing. The same is utilized for PIR timing up to 12 contacts, for which you need to enable the PIR in the software. Thus the same contacts can be used for 12 main and 12 PIR timings, which covers 4 breaks per pole in a single operation. Module 6. Auxiliary Contact Timing Module. The maximum auxiliary contact which can be provided is 12 numbers as shown in the figure beside. As a standard, we provide 8 auxiliary contacts. Either 8 or 12 can be used to sense either dry or wet contacts. Module 7. DCRM plus Communication Link Module. This is a very important module. It is used to connect either 1, 2, 3 or 6 channel DCRM. We can connect from any of the 3 connectors to use either 1 or 2 channel DCRM. Similarly, we can use all 3 connectors to achieve either 3 channel or 6 channel DCRM. All this is possible through the software. Module 8. Analog Measurement Module. This module is used for measurement of the analog values such as motor current, station DC, coil resistance, and PIR value. This module is also divided into 2 halves. The above half is used to measure the PIR value, whereas the lower 4 analog measurements are configurable and can be used as per the user's requirement. DCRM Plus units are very compact and lightweight, only 3 kg for 2-channel DCRM. Now let's look at the DCRM Plus unit for connectors available on it. From HISAC Ultima Module 2, Power Supply to DCRM Plus, connect to the left side port as seen in the above picture. Whereas to establish communication between DCRM Plus and HISAC Ultima, we connect to Module 7 DCRM link to the right side port. Ports are designed such that power and communication links cannot be interchanged. Also, there is a power on LED light, which could help the user to understand the status of the DCRM Plus unit. On the top of this handheld unit has the following connectors. 3 big connectors form current injecting sources, C1+, C2+, and C-, whereas small 4 connectors are used to measure the millivolt drop, namely V1+ and V1-, V2+ and V2-. Also, it has a big hook that is used to insert the rope to hang the DCRM Plus on the circuit breaker. Now we move ahead to the main segment, connection for CB testing using the HISAC Ultima with DCRM Plus. Going ahead, let us first make some assumptions so that we can look out for maximum connections. We would show the circuit breaker with double break. We would show for a single pole, the same can be replicated for the other 2 poles. We can split the connection into 2 parts, one which is connected directly at the circuit breaker and the other at the marshalling box and/or mechanism. Let's start with the connection at the circuit breaker. But before that, test which can be conducted by getting connection done at marshalling box or mechanism. Coil current, contact travel, station DC auxiliary contact timing, motor current, coil resistance, first trip. Whenever you are starting the connections, please ensure the following. HISAC Ultima is removed from the aluminum case. Connect the master earthing. Check the power supply voltage with the help of any multimeter. Line to neutral and line to ground. If within permissible limits, then only proceed. Connect the power cord at HISAC Ultima first and then at the source. Now we need to take control of the breaker. But before that, wait. Check if the breaker is open. Isolator is open. Earthing switch is closed from both ends. Check the indication in the mechanism box also to be double sure about the same. Once you have tested and confirmed this, let's take control of the breaker. From Module 3 to close coil, trip 1 and trip 2. Let's continue to connect the coil current at the mechanism box. Some breakers require the linear transducer, whereas some require the rotary transducer. This helps in calculating the electrical stroke length and mechanical stroke length of the breaker contacts that have moved. Let's continue to connect the travel and coil current at the marshalling box. The above figure shows the connection of coil current. Let's see which all tests are performed by this connection at circuit breaker end. Timing, main contact and PIR timing. Static contact resistance measurement. Dynamic contact resistance measurement. Pole discrepancy, bounces, and break mismatch. We would now look for the connection of DCRM+. So to power up the DCRM+, we will use the Module 2 on Ultima. It is the bottom side of the DCRM+ where we make connections. The second connection is for the communication link by using Module 7. Let us see how to connect those. Once communication and power supply is set up, we can go for a connection at circuit breaker end. This connection is very important. We always suggest the place where C-clamp would be mounted should be cleaned properly with sandpaper so as to avoid the multiple operations of the breaker. Here, the DCRM+ unit should be hanged first properly and firmly through the rope provided and through the hook. After this, all connections to the breaker are to be made from the top end of the DCRM+. Here is the complete view of how the connections are to be made. After all the connections are made, PC or laptop software to take over. You can see the graphical representation after the test is carried out. We are showing you an example of the DCRM test conducted. 1 channel DCRM, 1 travel and 1 coil current. 6 channel DCRM, 3 travel, 3 coil current. We can view, save and print the reports in the PDF format. Stay tuned for the second part in which we will try to explain how to effectively use the software and conclude the test results. We hope you liked the video. Stay tuned for more such content.
Thank you for your precious time. To know more about our products, visit our website.